Hi everyone, welcome to the channel again. In this video, we are going to learn about Pandas, which is one of the most famous libraries and one of the most important libraries for machine learning and data science. Like any other video on our channel, we are going to make use of our real world data and we are going to learn Panda by making use of Pandas, right? So let's get started. So what is Pandas at the very first stage? So Panda is a library provided with a high performance, easy to use data structures and data analysis tools. It provides three data structures. One of those is most important, that is data frame. So which is like a 2D table in the memory, something similar to a spreadsheet or which has named columns and rows, right? In the case of data sets which don't have these column names, we give them a numeric number that starts from 0. Many features available in Excel are available in Pandas in a programmatical way, such as you can create pivot tables, you can compute columns based on other columns, you can plot graphs, etc. You can also group data between different columns, something similar to MySQL, right? So talking about what are the prerequisites to this video, the only one is Numpy. You need to have some basic understanding of Numpy arrays. So if you don't have that, I'm going to put a link in the description to my videos on Numpy. You can watch that and come back to this video. Okay, talking about another important resource, I have put a link to that. This is a data sheet from DataCamp, which has almost all important functions of Pandas available. So it's like a quick review tool which you can visit anytime if you want to, if you get stuck somewhere or you forget something, right? So let's get started towards the code. Let's start coding it. Talking about the setup, so usually people import Pandas as PD. That's exactly what I did as well. So this is the syntax to do that. You write import Panda as PD like any other library of Python. Talking about the three data structures it provides, first one is series, second one is data frame, the third one is panel objects. So series are the objects that we will discuss now. Series object is a 1D array, very similar to NumPy arrays, right? 1D NumPy arrays, and it's more like a single column of a spreadsheet. Talking about the data frame, which I mentioned previously, it's like a 2D table. And the last one, panel object can be seen as a dictionary of data frames. Well, they are rarely used, so we are not going to discuss them in our videos. Let's move towards creation and use of series. So talking about how you can create a series. As I mentioned, they are very similar to 1D NumPy arrays. You can initialize them with lists, something very similar to NumPy. So the syntax is also very similar. You write PD, which is the short form of Pandas. Then you type series and then you give the list. Okay, so after that I'm printing the series and here is the output. So you can see it's like more like a column of a single column of a spreadsheet, right? Each and every element in the series has a unique number starting from 0 that specifies its index, right? And it's in or at the bottom it's printing the type of the series. As it's very similar to NumPy arrays, almost all functions of NumPy can be applied to those. So here what I'm doing is I'm importing NumPy and then I'm applying exponential function to this series. So what is going to happen is it's going to return you another series with that particular operation applied to each and every element of the series. Like the first element is the exponential of 2, the second is the exponential of -1, etc. Talking about the arithmetic operation, so again it's very similar to NumPy. If you give it a matrix or a 1D list having exactly same element numbers to that of series, is going to add in perform the operation on each and individual element. That means here we are going to have 1000 added to 2, here 1000 added to uh, again to 2000, that results in 199 and so on. If you try to add a single scalar to it, that scalar is going to be added into each and every element. Talking about the Boolean operation, again, it's going to be applied on each and every element of the series. Like if you apply this comparison, it's going to compare each and every individual element of that, and it's going to give us a series of Boolean that's going to correspond to true and false depending upon the condition being applied to every element. Talking about indexing or referring to the elements. So by default, it gives numerical numbers to each and every element, but a good way to do is to give it names to each and every element, and this is the way to do that. You pass a list of names, right, list of strings to the series while initializing it, right? So Alice is going to correspond to 68, Bob is going to correspond to 83, and so on, something very similar to dictionaries of Python. Now, in order to assess the elements, you can go with two ways. One is you can assess the value of corresponding to that location by giving it a name as an index. Second is you can give the column number as row number as well. But there is a flaw with using this particular notation. So the better one is mentioned here. The first one is you use a keyword of lock that specifies location. So you will say s2 dot then you give the name of the index Bob, or you give the number of the index. And if you are specifying to number, then you need to write I with location. It's going to be index location. Talking about now, here is the catch. Okay, talking about the slicing, so you can do slicing very similar to Numpy. So this is going to return us another series that is going to have the elements starting from the first one and till one less than the last one. So that means 1 and 2 indexed 1. These two are to be returned. Right. So now here is the catch. If we let's talk about that, which I previously mentioned, that there is a problem with using that original notation of indexing. That is like, let's create a new series, right? It has these elements and we name it surprise. Okay. Now if we slice it like this, that this means that including the second element till the end of the series, very similar to NumPy, right? As it returns as the surprise slice. Now you may see that the location is not starting from 0. Now, in this case, if you are trying to assess it like this is going to generate an error, right? That's why I put it inside a try exception block, and it returned me a key error of 0 type, right? And if you want to get this element, which in fact is at the 0th location, then you should use this location method of assessing it, right? So it's always recommended to use the location methodology to index to get the values out of index. Okay, talking about initializing the series with the help of dictionaries. So you, as I have shown previously, that series means or are very similar to dictionaries if you give the indexed names, right? So that make it obvious that it should be capable of getting initialized with dictionaries, right? And that is very much possible. So here I created a dictionary. That dictionary is corresponding to 4 values, right? We have the key, we have the value, right? Now I put that as the input while initializing or creating a series, and here we have the series that is being created by the dictionary. Okay, you can also create another series from a dictionary by telling it that you want that particular values of the dictionary, right? And this is the way to do it. You told it that you only want the values of corresponding to these two entries in the new series being created, that we are calling as S4. Okay, so it's going to create a series that is going to have only the values of Colin and Alice keys, and the sequence of elements inside the series is going to be followed in this way. So it's going to be the first one is going to correspond to the first key, the second one is going to correspond to the second key. Okay, talking about plotting of the series, so you can plot it with plot function. Okay, talking about the first line, so you can ignore this line. These are called, all the statements starting with this percentage marks are called magic lines. These magic lines are basically to control the functionality or the working of the Colab. So talking briefly about this particular one, this says that print the picture on the Colab notebook right after this code. Okay, but you can totally skip this. This is basically IDE dependent. Okay, talking about now next I imported matplotlib dot py as plt. The reason is I want to call the function of plot show, right? I created a new series, I named it temperature, right? You can give it a name as well. Okay, if I remove this, it's going to be creating no effect. Okay, first I created a list, then I created a series out of that list, and I called a function dot. By calling dot plot is going to create a line plot out of that data present inside the series. So as 0 is something like, on 0th location we're going to have 0 4.4, on 1 it's going to be 4.1, and so on. Those values are here on the x-axis. The actual values of the data are plotted on the y-axis. Moving towards the important part of pandas, the important data structure, that is data frame. Okay, so as I mentioned previously in the start of the video, we are going to play with a real world data like we used to do with majority of the videos we make on the channel. We are going to make use of a data from Wisdom Lab from Fordham University. It's a data set that has the data of accelerometer of a smartphone that was placed inside the pocket of a volunteer while he or she was performing some activity. So it's a data set for human activity recognition. It has, okay, it has 6 columns. So talking about, let's first talk about this code. Okay, so you may just ignore it for the time being. This is totally irrelevant of pandas. What I'm doing in this block is I'm cloning the data set, I'm downloading the repository, and I'm unzipping it and bringing the data set available to the a virtual instance I got on the Colab, right? All these are bash commands, so nothing related to pandas. Coming at this stage, we are going to have this particular file downloaded into our Colab instance, and I initialize its path to file path. Talking about creating, how to create a pandas data frame. Okay, so pandas data frame is, you can directly read a file inside a pandas data frame by creating it. So this is the syntax to do it. You call pd.read_csv, you give the path of the file, and then header is equals to none is going to be same for majority of the cases, so I'm not getting into the details of that. The next parameter you need to initialize is you need to tell it how many rows are there in the data file. Okay, so I have mentioned few statements here which are important. Let's go through them. First is, the motivation of using the real world data set is to get you familiarized with the problems that being faced when dealing with such data. So there are some problems with almost all the data sets available out there. All the real world data sets. I'm not talking about the dummy data sets which are there for teaching machine learning, right? Okay. The first or the most common issue is that columns names are not given there. You need to read the documentation to get the idea, right? Okay. Well, that is not a problem, but you should add the column names in your code because that creates an ease in coding, right? So the next is, usually the data sets have missing entries, and there are some extra characters being appended to numerical data. So let's get into that, and I elaborate that in detail. Okay, so first of all, we created a data frame. You can remove this line. Okay, I named it data frame underscore problematic. Okay, I'm going to fix those problems. The first important function is head. uh, the head function prints the first 5 values of the data frame, right? So it is always good to call this at after initializing or reading the file to get an idea that whether the data is properly read or not. Okay, so it also gives you the picture how the data is being represented in the memory, right? We can see we do not have the column names here. First thing. The second thing is, we have a semicolon being appended to this numerical data. Okay, so let me tell you what the data in what each column actually specifies. The first one is the user ID. This is the ID of those volunteers, a unique ID assigned to all the volunteers who participated in the collection of the data. The second specifies the actual activity the person is performing. The third is the timestamp, right? This the fourth one is, this one is the x-axis value of the accelerometer. The second one is y-axis value, and the third one is z-axis value. So these 3 values should be numeric. Okay, if you talk about Python, you know it's a dynamically typed language. So what it means is that it specifies the particular type to the data depending upon the nature of the data, right? So it's always good to actually check what Python is understanding from each and every column, right? So the basic case is that these are the numeric values corresponding. In the case of classification, we need to use these numeric values to train or any classifier to predict these classes, right? So that data should be taken as numeric data by Python, right? Let's check it. The way to check it is to use info function. Your call info function is going to print you the basic summary of each and every individual column. Okay, so we get that the first one is taken as integer, the second one is taken as object, this one, the third one is taken as integer, the fourth one is taken as float, third one is taken as float, the fifth one or the sixth one, by the way, this one is taken as object. Object means string. Now the problem is, if there is any sort of a character being appended to the numerical data, Python is going to take it like string, and you cannot give that string type of data to any classifier for training. Now you need to bring into float values, and you cannot directly do that. The reason is, float, any conversion function is not going to take something that has a character thing attached to it. Okay, you need to remove that. Let's do that. Now let's go through this. It says now two issues are there for the data set. Number one, does not have column names. Okay, we talked about that. Number two, the z-axis is taken as an object. That should be float. It's a big problem. The first one is not a big problem. We know z is the numeric nature and will be used by the classifiers for training. The reason is that there is a character appended to it. Okay, we talked about that, right? Okay, first thing first, let's do the everything from the beginning and import it in a nice way. Okay, I created a list and I gave it fancier names, or you may say easy to understand names corresponding to the nature of the column. Okay, the first one is user ID, activity, timestamp, x-axis, y-axis, z-axis, right? Next, I read the data. I created a new data frame. I read the file again and I gave a parameter that is name equals to column names. Okay, I didn't say n rows is equals to 6. I simply gave it a list, right? List of 6 elements. I know there are 6 columns, right? I got that information from documentation. Now I printed the head. Now I see, okay, there's one more thing I did in the last line. That is, I replaced the semicolon with blank integer. Okay, this is the way to do that. You say, okay, you can refer to any column by using this particular this index notation. Now this is the good thing about using the names or giving the names to the columns, right? I could have assessed it like 5 here, but the good way is, which is easy to understand way is to give the name of the column, right? Very similar to series. Okay, I called a function replace, and you can take these two parameters as is. This simply means that replace the character and put that character right at the location where the previous character is replaced. You can replace it with another character. Okay, what I did is I gave it a blank character, no character. Now I printed again with the help of head. Now we see that this is also clean up. Now this is cleaned up, but Python is still taking it as an object. Now you need to convert it into float. For that, I made use of Numpy. I imported Numpy, created a function convert to float. I put a try catch there, a try catch block. In the try catch block, I said whatever value you get, you return it as a float, convert it to float. Else return nan or blank, right? Uh, this is important to put this thing here. This dataset does not have a blank entries, but it is possible that some datasets have blank entries and you may get a blank. So you cannot convert that to float, right? It may generate an exception. So for that I put nan here. So if there is some exception, return an nan, nothing. Okay, this is the way to call any of your function you want to apply on any column of the data frame. I said make data frame of index z axis equals to data frame of index z axis and apply this particular function. So it's going to put each and every value. It's going to call this function for each and every value, and then it's going to get the value returned for that each and every value. And now when I checked, z axis is cleaned up, right? And at this stage, our data is cleaned up and in a form where we can use it to train any classifier, right? Okay, now you may also save your cleaned up data. You did some effort, you want to save it for future. You can save it to another CSV file by calling this function. To CSV is going to generate a CSV file, right? Well, this is a new instance. If I run this code, let's run it. After this line, I will be having a file generated here, and I can call that, right? Let's see what's the issue. Let's remove this, run it again. Yeah, everything is working now. Let's run everything again. Run after. Right. Now, let's come back to the location where we were, right? Okay, everything is running perfectly. By the way, you are going to get the link to this notebook in the description of the video, right? Okay, so at this stage, the file should have been created. Let's check. Yes, the file is created, and this is the code to download the file, right? You can download it on your system and check whether it is up to the mark or not, right? Talking about plotting uh, the the values in the data set, right? You get the data set, you need to get some insights, right? So first thing first, one important aspect of the data you always need to know is that whether the data set is balanced or not, right? So that means that whether the data set has equal number of entries for each and every class or not, right? This is the way to do that. We know that the activities are there in the activity column, and we can call a function, say value underscore counts. It's going to print the number of entries for each and every differentiating value inside that column. So we have 6 activities here. We are getting the entries for it. In order to plot that, you make use of matplotlib. We get these values till here, then we call a plot function, and we say it create a bar chart and give it a title. After that, we called the function show of plt to plot those values. So this gives us a bar chart which specifies that this is not a balanced data set. Okay, talking about the practice task. So I'm going to put a link of this data set. Yeah, so by the way, the file is downloaded. We are going to check after going through this practice problem. So I'm going to put the link to this file inside the description of the video. So what this file has, it has a data set of EMG data for gesture classification. Your task is to load this data set, this file, check whether there is any problem inside the file or not. If there are any problems, you need to remove those problems, and then you have to print such a graph to see whether it's a balanced data set or not, right? Let's go through the file which we have downloaded. Okay, let's see, is it in a form we wanted it to be or not. Yeah, usually the data files are very big, so it shows you the warning. Yeah, it is in the form we wanted it to not to be wanted it to be, right? Good. So that is it for this video. In the next video, we are going to move towards some classification problems, right? We are going to train some classifiers, different classifiers, etc. So stay tuned. If you have not subscribed, so do subscribe and do give us a thumbs up. Thank you very much.